Okay. Okay. So, hi everyone. So, good afternoon. Good afternoon, all. Right. Okay. Shalu Kumari, good afternoon. Alok Kumar, good afternoon. Okay. Okay. So, so good afternoon to everyone here. Good afternoon. So, Divya Bharati, good afternoon. Right. Okay. So, we are dealing with the topic magnetostatics. Yes or no? We are dealing with the topic magnetostatics. Right. So, we are dealing with the topic magnetostatics. So, in the previous session here, so just I will revise whatever we have done. Okay. So, in the previous session, what we have done here? So, we have seen I have given one statement here. Yes or no? So, what is that statement I have given? So, magnetism is caused by only moving charges and is also felt by only moving charges. Yes or no? So, what I have given? So, magnetism is caused by moving charges and is also felt by what? And is also felt by only moving charges, right? Okay. So, this is what we have seen here. So, what do you mean by this here? So, what do you mean by this? Magnetism is caused by only moving charges means, so a stationary charge cannot produce any magnetic field, yes or no? So, if the charge moves with a uniform velocity, then it is going to produce a steady current, and that steady current is going to produce what? Magnetic field. So, that means the moving charge, the charge that is moving with uniform velocity is causing the magnetism. Yes or no? And magnetism is also felt by what? Is also felt by only moving charges. So, if you place a stationary charge in magnetic field, it is not going to experience, any force here. Okay. So, Kumar, good afternoon. Good afternoon, Kumar. Okay. So, I forgot to ask here if audio and video is anything, if there is any problem in audio and video, please give some comment in chat box here. Divya Bharti, sir, actually last week only I have started learning EMT of your previous lectures. I have little bit confusion in horizontal and vertical component. Will you clarify it by now? See, now I don't know regarding which lecture you are asking. Okay. Okay. We'll continue with this topic here. We'll continue with this topic because all the other students are also watching this now. Okay. So, you just join my Telegram group, Divya Bharati. Okay. So, there you can ask your doubts. I will clarify that. Right. Okay. 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 So, in the previous session, I have told that magnetism is caused by moving charges and is also felt by moving charges. Yes or no? So, next what I have done here, what we have studied next. So, we have studied a Lorentz force equation. Yes or no? We have studied Lorentz force equation for what? For B field. Lorentz force equation for B field. So, what is the Lorentz force equation for B field here? So, F is equal to what? F is equal to Q into what? Q into V bar cross B bar. Q into V bar cross B bar. Right? Okay. Okay. So, that means if the charge is moving, with uniform velocity in magnetic field B, then it is going to experience a force. So that means if the velocity of the charge is equal to 0 here, if the velocity of the charge is equal to 0, then that charge is not going to experience any force in magnetic field. Only a moving charge can feel what? Can feel magnetism. A stationary charge cannot feel any magnetic force. Okay, so that's what we have studied here. So F is equal to Q into V cross B is the Lorentz force equation for B field, whereas for electric field here, for electric field, what is the Lorentz force equation here? For electric field, the Lorentz force equation is F bar is equal to what? F bar is equal to E bar into Q, E bar into Q. This is for electric field and this is for what? This is for magnetic field. Yes or no? Okay, so based on this here, based on this, so I have represented here with the subscript B and here I have represented with E. Right? Okay. 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 So Divya Bharti, you can post your doubt in Telegram channel here. Okay. So definitely I will give, I will clarify your doubt. Right? Okay. Okay. Yeah. So and then we have seen that whenever a charge, let us say plus Q here, let us say plus Q. So if plus Q is moving in this direction here, so we have considered this as x-axis and this as y-axis and z-axis is coming out of the board, right? Okay, so we have considered, let us assume plus Q is moving in this direction, that is in x direction. Understood? Velocity is in x direction. So let us assume B field here, B field here is pointing into the board. Let us assume B field here is pointing into the board here. B field is pointing into the board. Okay, so then in this case we have taken different cases here. Yes or no? We have taken different cases and try to determine in which direction the charge is going to experience the force. Yes or no? So if the B field is pointing into the board and if the charge is moving along x direction and this is B field, it is pointing in negative z direction, then in which direction plus Q is going to experience the force here? We have seen that. Yes or no? In which direction it is going to experience the force? It is going to experience the force in which direction? It is going to experience the force in upward direction. Yes or no? See here, see F is equal to what? F is equal to Q into V bar cross B bar. So what you will do here is V is along x direction, B field is along negative z direction. So one thing is you can do here x cap cross what? Minus z cap, that is ax cap cross minus az cap. What you are going to get? You are going to get ay cap. You are going to get ay cap. So in this manner you can find out the resultant force direction, or what you can do here, this is nothing but what? This is nothing but cross product between what? V bar and B bar. So B bar is pointing into the board and velocity is pointing in this direction. So B bar is pointing into the board and the velocity is pointing in this direction. Yes or no? So you are doing the cross product between V bar and B bar. So if you curl your right hand fingers here, if you curl your right hand fingers from V to B, yes or no? It is going to give you what? It is going to give you the force direction. Yes or no? How you can determine the resultant of cross product here? How you can determine the direction of cross product? How you can determine? So take your right hand and curl your fingers from where to where? From V bar to B bar. So V bar is pointing in this direction and B bar is pointing into the board. So if you curl your fingers from V bar to B bar, right hand fingers from V bar to B bar, then the thumb is pointing in upward direction. That means the force is going to point in which direction? Upward direction. Understood? Okay. So in the same case, if suppose if I have considered instead of plus Q, if I have considered minus Q here, if minus Q is moving in the B field that is pointing in negative z direction, so let us assume the velocity is in x direction. Understood? Okay. So in this case, what is the direction of the resultant force here? What is the direction of resultant force? So here in this direction, in this case, what you have to do? F bar is equal to, here you are having minus Q here. Minus Q into what? Vx cap cross what? Cross B minus z cap. So here also you can do the cross product here. Cross product between V bar and Z bar. So if you do the cross product between V bar and you have to do the cross product between V bar and B bar. So V bar is pointing like this, okay, so B bar is pointing into the board, so V bar cross B bar is the resultant force will be in upward direction. But here again you are multiplying this with what? With minus. Yes or no? So that means the resultant force will be in which direction here? The resultant force will be in downward direction. So determine this resultant force direction and multiply with what? Multiply with minus. Okay, that is going to give you the final resultant force direction. Understood? Okay. Okay. So in this manner also, by using your right hand also, you can easily determine the resultant force direction. Right? Okay. Yes, Alok Kumar, through screw rule or right hand thumb rule, everything is same here, right? Okay. So the final conclusion will be same, right? Okay. See, what do you mean by this? F bar is equal to, I can write the same thing as Q into what? If I multiply with minus, I can write this as what? B minus Z bar cross what? V X bar. In this manner also I can write or not? Yes or no? If I multiply with minus here, see, we know that A bar cross B bar is equal to what? A bar cross B bar is equal to, I can write minus of what? B bar cross A bar. Right? Okay. Okay. Yeah. Okay, so that means I can write F bar is equal to what? F bar is equal to Q into what? Q into minus of what? Minus of Vx bar cross what? B minus Z cap. Understood? Okay, so if you multiply with minus, what do you mean by that? It is nothing but simply B bar minus V bar. Okay, so in any manner here, finally you are going to get the same result. I am telling you different ways. That's it. Okay. 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 So I hope you have understood how to determine the force. Yes or no? Okay. Okay. Now in today's session we will see the application here. Application of this Lorentz force equation. See, I have told the Lorentz force equation for B field and this is the Lorentz force equation for electric field. Suppose if you are having both magnetic field as well as electric field here. So in that case, how to write the Lorentz force equation? You are having both magnetic field as well as what? Electric field. So in that case, how to write the Lorentz force equation? So Lorentz force equation, whenever you are having what? Whenever you are having both B field as well as what? B field as well as electric field, okay, so both B field as well as electric field. If you are having both the fields, then how to write here? How to write? See, due to B field, what is the Lorentz force equation? F bar is equal to what? Q into V bar cross what? V bar cross B bar, plus due to electric field, what is the Lorentz force equation? Q into what? Q into E bar. So this is the Lorentz force equation for both what? For both B field and electric field. If both the fields are present, then you have to write in this manner. Okay, so therefore F bar is equal to what here? F bar is equal to what? I can take common? Q I can take common. So you are going to get E bar plus of what? E bar plus of V bar cross B bar. So in this manner I can write the Lorentz force equation. Lorentz force equation if both the B field as well as electric field both are present. Understood? Okay, if we are studying only about the B field, okay, if you are considering only B field, then you have to consider only this term here. Okay, if you are dealing with only electric field, then you have to consider only this term. So if you are dealing with both B field and electric field, okay, in a region, if you are having both the fields, then you have to consider the total equation, right? Okay. Okay. So now we will see the application here. We will see the application of this Lorentz force equation. Okay, we will see the applications here. We will see the applications of Lorentz force equation. Lorentz force equation. Okay. Okay. Now see here. So mostly you will study the application of this Lorentz force equation in EDC while dealing with what? While dealing with Hall effect. Okay. See, most of the concepts here, most of the concepts that you are going to study in EMT will be very much helpful in learning EDC. Not only EDC here, some other subjects also, in learning network theory, okay, in learning analog circuits, communication, whatever may be the subject. So for each and every subject, the basic subject that you need is nothing but EMT. Okay, all the concepts were derived from this subject only, right? Okay, so if you see KVL will come from here only, KCL will come here only. Okay, continuity equation, Laplace equation, Poisson's equation, right? And then Lorentz force equation. So all this here, all these applications are present in EDC also, right? Yes or no? Okay, and KVL, KCL and Ohm's law, all these things are applications in network theory, right? Okay. Okay, so when we enter into wave spot, so that is the application, we are going to have that wave spot application in communication. So each and every subject here, almost all the subjects in EC and electrical stream, they are having the basic concepts that are present in this subject here. Okay. Okay. Okay, so first we will see the applications of Lorentz force equation. So now see here. So here I am considering a semiconductor here. I am considering a semiconductor. Okay, let us say this is semiconductor here. This is semiconductor. Okay, that is extrinsic semiconductor. Extrinsic semiconductor. So that means it may be P type or it may be what? N type. Understood? So it may be P type or it may be N type. I don't know that. Okay. Okay. Yeah. So now I want to determine whether this extrinsic semiconductor is P type semiconductor or N type semiconductor. That's what I have to determine here. So what I am going to do here is, so I am going to connect here. So here at this ends I am going to connect a voltage source. I am going to connect a voltage source here. Okay, so once I connect this voltage source, so then the current is going to flow from where to where? From left to right. The current is going to flow from left to right. So here the current is flowing in this direction. The current is flowing in this direction. So let us consider this is x-axis, and let us consider this is what? This is y-axis, and let us consider this is what? This is z-axis. Okay, this is z-axis, right? Okay. Okay. So this is potential V I have applied. Okay. So now now I am subjecting this intrinsic semiconductor, I am subjecting this semiconductor to a transverse magnetic field. So what do you mean by transverse magnetic field here? Transverse magnetic field means that B field must be perpendicular to what? Perpendicular to the flow of current direction. Yes or no? Okay, so that's what I am calling it as transverse magnetic field. Let us assume the transverse magnetic field is pointing in Z direction. So this is the transverse magnetic field that is pointing in Z direction. What do you mean by transverse magnetic field here? It must be perpendicular to what? Perpendicular to the flow of it must be perpendicular to the flow of current direction. Understood? Okay, so B field is pointing in which direction here? Positive Z direction, and here the current is flowing in which direction? It is flowing in X direction. Okay. Okay. So I have subjected a semiconducting material in a transverse magnetic field, and I have applied a potential across this what? Across this semiconductor, such that there will be a current flow through this semiconductor. So a current carrying semiconductor is placed or subjected to a transverse magnetic field. Understood? So then what will happen? We will see. So I don't know what is this type of semiconductor here. What is this semiconductor? I want to determine which type it is. Okay. So first of all, what I will do here is just I am doing the analysis here, right? Okay. So first I am making an assumption here. Okay, so here I am assuming that it is P type. I am assuming that it is P type. Okay, I am assuming that it is p type. So now see here, so let us say this surface here, let us say this surface is A and this surface, top surface, I am considering as B. So you have to so bottom surface I am representing with A and top surface I am representing with BR, right? Okay, so I am assuming that this semiconductor is a p type. So if I consider it as a p type here, the majority charge carriers are nothing but what? Are nothing but holes. That means positive charge carriers. Okay, so the current is flowing in this direction means the positive charge carriers are going to flow in this direction. So I am assuming here, this as p type. Right. So if I assume this as p type, the majority charge carriers I am representing with plus q. I know that it is positive charge carriers. Understood? Okay. So now if you observe here, so this positive charge carriers here, this positive charge carriers plus q. Understood? This is positive charge carrier. Now this charge carrier is moving from where to where here? From left to what? From left to right. Yes or no? So plus q is going to move along the direction of what? Along the direction of current. Yes or no? So this plus q charge, all the positive charge carriers are moving in which direction here? Are moving in x direction. Now what is the direction of B field? B field is pointing in which direction? B field is pointing in z direction. So this is B field here. B field is pointing in z direction. Now tell me in which direction these positive charge carriers are going to experience the force here? We know that whenever the charge carriers are moving in a magnetic field, they are going to experience a force. Just now we have seen from Lorentz force equation for magnetic field. Yes or no? So here this positive charge carriers, plus q represents all the positive charge carriers that are flowing from left to right. Understood? Okay. So all the positive charge carriers are flowing from left to right. And here the magnetic field is pointing in positive z direction. Then all these positive charge carriers are going to experience a magnetic force in which direction? Tell me. In which direction they are going to experience the magnetic force? Tell me here. Alok Kumar, tell me in which direction it is going to experience the force? Magnetic force. We know that Fb is equal to what? Fb is equal to plus q. Yes or no? Plus q into what? It is the velocity is in x direction and B field is in positive z direction, right? Positive z direction. Now in which direction it is going to experience the force? Tell me. It is going to experience the force downward. Downward means in which direction? Here I have given the coordinate axis now. Downward means it is negative y direction. Yes or no? Okay. Okay, yeah. So x cross y is nothing but minus y. X cross z is nothing but minus y. So it is going to experience a force, magnetic force in which direction here? In negative y direction. So what will happen? All the positive charge carriers are flowing from left to right in the magnetic field, in this transverse magnetic field. So because of this transverse magnetic field, these positive charge carriers, this moving positive charge carriers are going to experience a magnetic force, in downward direction, So what will happen here? All the positive charge carriers will come and accumulate. They are going to experience the force in downward direction. So they will come and accumulate on the bottom surface, Understood? Now if all the positive charge carriers are coming and accumulating in at the bottom surface, so what will happen at the top surface here? So at the top surface there will be a deficit of what? There will be a deficit of positive charge. So that deficit of positive charge, you can account it as what? You can account it as negative charge. Yes or no? You can account it as negative charge. So now here the magnetic force is acting in downward direction. So all the positive charge carriers come and accumulate at the bottom surface. So at the top surface there is a deficit of what? There will be a deficit of positive charge carriers. The deficit of positive charge carriers can be accommodated as what? Accommodated as negative charge carriers. Yes or no? Okay. So on the top surface there will be a negative charge carriers, on the bottom surface there will be a positive charge carriers. So we know that whenever you are having, so bottom plate you are having positive charge carriers, and on the top plate you are having negative charge carriers. So what will happen here? Whenever you are having here positive charge and here negative charge, what will happen? There develops an electric field between this positive and negative charges or not? Yes or no? That means there induces an electric field. Between the bottom surface and top surface. So the electric field will always point in which direction? The electric field will always point from plus to what? From plus to minus. So the electric field here is going to point in upward direction. Electric field is pointing in upward direction. Understood? Okay. So whenever electric field is pointing in upward direction here, so here you are having plus Q, right? Okay. So okay. So here itself I will draw here. So here you are having plus Q. So because of this magnetic force, it is going to experience the force in downward direction. So because of this, there is a accumulation of positive charge at the bottom plate, and there will be accumulation of negative charge on the top plate, and hence because of this, there induces an electric field between top and bottom surface. Okay. So whenever the electric field is pointing in this direction here, what will happen? So this charge here, this positive charge now is going to experience a force due to this electric field or not? Yes or no? So that's what I have told here. Fe, the electric field, because of this electric field, what will happen? So it is going to experience the force, plus Q is going to experience the force along the direction of what? Along the direction of field. So the field is pointing in which direction? Y direction. So this electric force will point in which direction? Yeah, this electric force is also going to point in upward direction. Understood? So that means the electric force will try to pull the positive charge carriers in upward direction. Yes or no? So the electric force here is going to act in which direction? It is going to act in upward direction. Understood? So initially what is happening? The charge carriers are moving like this, the B field is like this. Okay. So because of this B field and the charge carriers are moving, so because of this velocity and B field, it is going to experience a force in downward direction. So whenever it experiences a force in downward direction, all the charge carriers will get accumulated. Positive charge carriers will get accumulated at the bottom, and at the top there will be a negative charge carriers. So because of this, there develops what? There develops a electric field. Yes or no? Okay. So now this electric field, so now what will happen here? Because of this electric field, these charge carriers will also going to experience electric force in which direction? In upward direction. So this process will continue here. See, still because of this magnetic force, further and further accumulation will take place. If the accumulation increases, then this electric field will also going to increase. Yes or no here? Then this electric field is also going to increase. As the electric field increases, this electrical force is also going to increase. Yes or no? So because of FB, accumulation is going to increase. As the accumulation increases, FE will also going to increase. At one stage, what will happen here? This electrical force will become equivalent to what? Will become equivalent to magnetic force. Yes or no here? So that's what we call as equilibrium condition. So under equilibrium condition, this electrical force will become equal to what? Will become equal to magnetic force. So initially only magnetic force is acting. So because of this magnetic force, there will be accumulation of charge. Because of this accumulation, there develops an electric force opposite to what? Opposite to magnetic force direction. As the accumulation goes on increases, this electric force will also goes on increases. At one stage, this electrical force will become equivalent to what? Magnetic force. So that condition we call it as what? Equilibrium condition. So once these two forces, the two forces that are acting on the charge here, now the electric force is acting in upward direction. So under equilibrium condition, this magnetic force and this electric force will become equal. Then the net force experienced by this plus Q will become what? Will become equal to 0, and hence it is going to move, it continues to move along from left to what? From left to right. It neither move downward nor move upward under equilibrium condition. Why here? Because both the forces will become what? Will become equal. Understood? Okay. Okay here. So understood here this one? Is it clear? Alok Kumar, Rahul Thakur, tell me here. Tirumalai, good afternoon. Good afternoon, Tirumalai. So is this clear here? So what will happen here? Under equilibrium condition here. Under equilibrium condition. So under equilibrium condition. So what will happen? What will happen? This electric force will become equal to what? This electric force will become, or I will write in this manner. Okay. So this magnetic force will become equal to what here? Will become equal to what? Magnitude of magnetic force will become equal to magnitude of electric force. Yes or no? And both are acting exactly in opposite direction. First you are having only magnetic force, so because of this accumulation takes place, and because of this there develops a electrical force which exactly opposite to magnetic force. Since both are exactly opposite to one another, at one stage what will happen? The two forces will become equal. That condition we call it as what? Equilibrium condition. So now here magnetic force is nothing but what? Plus Q into V into B, and electric force is nothing but what? Is nothing but E into Q. E into Q. Yes or no? Okay. Okay. So now here Q will get cancelled, and VB is equal to what? VB is equal to E. Here V represents what? V represents velocity here. V represents velocity. I am representing this with V here. Okay. So V represents velocity. Now here this is the electric field. This is the electric field that is developed. Between the bottom and top plate. Yes or no? Okay. So see here. So now I want to write this electric field in terms of what? In terms of potential between A and B. So VAB, we know that VAB is equal to what here? VAB is equal to integral E bar dot what? E bar dot. Yes or no? VAB is equal to integral E bar dot what? E bar dot dl bar. So this is equal to integral A to B here. Integral A to B. So this is equal to integral A to B. So E bar is pointing in which direction here? E bar is pointing in upward direction, that is in Y direction. So electric field is in Y direction. Okay. So dot dl. So this differential length also I am considering in upward direction. Understood? Okay. So this is equal to what? This is equal to E into dl integral A to B. Integral A to B. So VAB. So therefore VAB is equal to what? VAB is equal to, I can take E outside. So integral dl is nothing but what? Integral dl is nothing but L. Integral dl is nothing but L. Okay. Integral dl is nothing but L. Its range is from where to where here? From A to B. So that is equal to E into what? E into B minus A. E into B minus A. So E into B minus A will give you what? Will give you this height or not? So let us say this height here. Let us say this height is H. Okay. Let us say this height is H. Okay. So if you sub B minus A will give you what? Will give you this height H. So in place of B minus A you can replace with what? You can replace with H. So E into H here. So VAB. So therefore E is equal to what? E is equal to VAB divided by what? Divided by H. Okay. So therefore here I can replace V into B is equal to what? Is equal to VAB divided by what? Divided by H. Therefore VAB is equal to what? Is equal to B into V into H. B into V into H. Understood? Okay. Okay. So what we got here? VAB, the potential difference between A and B, we got it as what? We got it as some positive value. Yes or no? So if VAB is positive, means we can say bottom plate is what? Bottom plate is positive with respect to what? With respect to top plate. So here what we got here? We got VAB is what? VAB is positive, or I can say VBA is negative. Both are same or not? Yes or no? So depending upon this VAB or VBA, I can say the bottom plate is what? The bottom plate is positively charged, and the top plate is what? Top plate is negatively charged. Understood? Okay. Okay, yeah. So now see here. Now similarly here, if I do the analysis here, now I have assumed it as what? P type. Now if I assume it as N type here, okay, so then what will happen? We will see. Okay, so the same analysis here. Now tell me, can you guess here what you are going to get? Can you guess what you are going to get? Just to tell me in which direction the magnetic force is going to act. Tell me. I am not changing anything here. Okay, so the B field is pointing in Z direction. This is B field, right? Okay, so here I have applied the potential voltage. So the current is flowing in X direction here, right? Now here I am considering it as what? I am considering it as N type. I am assuming it as N type. Okay, so if it is N type, what are the majority carriers here? The majority carriers are nothing but what? Electrons. Yes or no? That means negative charge carriers. So the current is flowing in this direction means the negative charge carriers are flowing in which direction here? The current is flowing from left to right means the electrons or negative charge carriers are flowing from where to where? Tell me. Right to left or left to right? Tell me here. Tell me, Alok Kumar, Rahul Thakur. Tell me. It will be right to left or left to right? In which direction the electrons are moving? The current is flowing. I have applied the voltage here. So the current is flowing in this direction, right? If the current is flowing from left to right means the electrons or the negative charge carriers are flowing in which direction? Tell me here. So we have considered this as X axis, Y axis, and this is Z axis. It is Alok Kumar, current is flowing from left to right. So negative charge carriers will flow from where to where? From right to left or not? Yes or no? Okay, maybe you have confused here between left and right. Rahul Thakur, yes dear, yes. Right to left, right. Alok Kumar, the current is flowing in this direction means the negative charge carriers are flowing in this direction, that is right to left. Yes or no? So here the negative charge carriers, the electrons, I am considering the total number of electrons, I am considering it as minus q here, minus q. Okay, so this minus q is going to move in which direction? From right to left, from right to left. So the velocity of negative charge carriers will be in which direction here? In negative x direction, So that means it is in negative x direction. Now in this case, in which direction this minus q is going to experience the force? Now here you are having minus q, right? And B field is acting in which direction? Positive z direction, right? And the velocity, so the velocity here, the velocity is in negative x direction, it is moving like this, right? And B field is acting out of the board, so it is BZ. Okay, so now in which direction it is going to experience the force? Tell me. The velocity is in negative x direction and the B field is in positive z direction. Now tell me in which direction this negative charge is going to experience the force. So the electrons are moving from right to left like this, yes or no? So all those electrons are going to have some negative charge, so that's why I am representing with minus q. So whenever minus q is moving in the direction negative x direction, then in the magnetic field B, then it is going to experience the force in which direction? Tell me. Tell me here. F is equal to what? F is equal to minus Q into what? Minus Q into V minus X cross B Z. Tell me here. Or what you can do? If you do V bar cross B bar, if you do V bar cross B bar, you are going to get the force direction in upward, but you have to multiply this V bar cross B bar with minus sign. So if you multiply with the minus sign, it is going to point in which direction? Downward direction. Yes or no? Okay. So it will be in which direction here? Negative Y. Negative Y. Very good. Okay. So the negative charge carriers here are going to experience the force in which direction? In downward direction. In downward direction. Okay, it is going to experience the magnetic force in downward direction. So now here the negative charge carriers are experiencing the force in downward direction. That means the bottom plate, at the bottom plate, which charge carriers are going to get accumulated here now? Which charge carriers are going to accumulated now? Which charge carriers will get accumulated at the bottom plate? Tell me here, which charge carriers? Now the electrons are experiencing, or the negative charge carriers are experiencing the force in downward direction. So that means all the negative charge carriers will come and accumulate at the bottom surface, So whenever it gets negatively charged here on the top surface, there is a deficit of what? There is a deficit of negative charge. So that can be accounted as what here? The deficit of negative charge can be accounted as what? Can be accounted as positive charge. Right. Okay. So so here also, initially the magnetic force is acting in downward direction. So because of this, the accumulation of charge carriers will takes place at the bottom plate and top plate. Okay. So now what will happen here? So because of this separation of charges here, what will happen? There develops an electric field between the top plate and bottom plate. So now the direction of electric field is going to point in which direction? The direction of electric field is going to point in downward direction. Now you are having negative charge carriers here. So this is FB. Okay. So FE is equal to, what is the electrical force here? Minus Q into what? Minus Q into E bar. So that means the negative charge carriers are going to experience the force, in a direction opposite to what? Opposite to electric field. Yes or no here? Yesterday itself I have told, if it is positive charge carriers, the direction in which they are going to experience the force is same as what? Is same as the direction of electric field. Yes or no? Positive charge carriers will experience the force along the direction of electric field, whereas negative charge carriers will experience the force opposite to the direction of what? Opposite to the direction of electric field. Yes or no? So that means electric field is pointing in downward direction, means electrical force is going to point in which direction? Tell me. Electrical force is going to point in which direction? It is going to point in upward direction. Yes or no here? Yes or no? Okay, electrical force is going to point in upward direction. So initially, because of this magnetic force, there will be a separation of charge carriers in this manner. Okay, so that means at the bottom plate there will be negative charge carriers accumulated, and at the top plate there will be a positive charge carriers accumulated. So because of this, there develops an electric field. Yes or no? So whenever there develops an electric field, this negative charge is going to experience the force, electrical force, in upward direction. Understood? So as this accumulation goes on increases here, this electrical force will also goes on increases. Yes or no? So at one stage what will happen? This electrical force will become equal to what? Will become equal to magnetic force. So that condition we call it as what? We call it as equilibrium condition. Now here this is nothing but what? This is nothing but A, and this plate is nothing but B. Now here we try to determine VAB. So under equilibrium condition here under equilibrium condition, so under equilibrium condition, so what will happen here? Under equilibrium condition, FE is equal to what? FE is equal to FP. So magnitude of FE is equal to magnitude of FP. Okay, so Fe is equal to, same here, Eq is equal to what? Fb is nothing but what? QVB. So this is velocity I am representing with small v, right? Okay, so now here VAB is equal to what? Is equal to integral a to b E bar dot what? E bar dot dl bar, E bar dot dl bar. Now here integral a to b, now E bar is pointing in which direction? Electric field is pointing in which direction? Downward direction. Electric field is pointing in downward direction, that means negative y direction. Yes or no? Okay, so it is pointing in negative y direction. So minus ay cap. So dot always I have told while doing integration, always take this dl bar as what? Positive, that is dl ay cap. So what you are going to get? You are going to get here integral a to b, I am taking minus outside, so E into what? E into dl. So if I take electric field outside, so then minus E into integral a to b dl, so that is integral dl L, that is a to b, that is a to b. So this is equal to what? Minus E into what? Minus E into b minus a, b minus a. So b minus a is nothing but what? This b minus a is nothing but h. Yes or no? Okay, b minus a is nothing but h. So here you are going to get what? Here you are going to get h. Okay, so therefore VAB is equal to what? Is equal to minus E into what? Minus E into h. Okay, okay. So from here electric field E is equal to what? E is equal to minus VAB divided by what? Divided by h. So substitute that here, substitute that in this expression, here QQ will get cancelled. So in place of E, substitute minus VAB divided by what? Divided by h is equal to what? V into B. Therefore VAB is equal to what? Is equal to minus B into V into h, B into V into h. Understood? Okay, now here what we got here? What we got here? VAB we got it as what here? VAB is what? Is negative. VAB is negative, or I can say VBA is what? Is positive. In the previous case here, whenever we are assumed as p type, so in that case what we got here? In that case what we got? So in that case what we got? When VAB is positive or VBA is negative. So this is for what? This is for p type we got. Now for n type what we got here? What we got? VAB is what? Is negative, or I can say VAB is what? Is, sorry, or I can say VBA is positive. Okay, so that means if you take the semiconductor here, right? Okay, so you don't know what is this semiconductor here. I have taken simply a semiconductor, and if you apply the voltage, across this, right? Okay, so if you apply some voltage across this, right, here the current flowing is Ix. So whenever the current carrying semiconductor is subjected to what? Is subjected to some transverse magnetic field, whenever it is subjected to transverse magnetic field. Understood? Transverse magnetic field. Now here I am considering this as A and this as B. So the potential difference between, based upon the potential difference between A and B, I can tell which type of semiconductor it is. I have done the analysis or not? Yes or no? First I have assumed it as p type. Okay, so if I assume it as p type, this is the analysis we got, this is the conclusion we got. Yes or no? So if I assume it as n type, then this is the conclusion I got. So based upon this conclusion, so if I take a semiconducting material and apply a voltage in this manner, now based upon the potential difference between A and B, that is VAB. Understood? Whether it is positive or negative. So based upon that I can tell whether it is what? Whether it is p type or n type. Understood? Okay, so if I got VAB as positive here, if I got VAB as positive, then I can say it is what? It is p-type semiconductor. Or if you can say the same thing in another manner, that is VBA is negative. So if VBA is negative, then also I can say p-type semiconductor. Or if VAB is negative, then I can say n-type semiconductor. Or VBA is positive, then I can say n-type semiconductor. So based upon this here, based upon the potential difference between A and B, I can conclude which type of semiconductor it is. Understood? Okay. Okay, yeah. So this voltage that is induced between A and B, we call it as what here? We call it as Hall voltage. We call it as Hall voltage. So based upon the Hall voltage, we can tell which type of semiconductor it is. Right? Okay. So I hope all these things are crystal clear here. Right? Yes or no here? Is this clear here? Tell me. Alok Kumar, Rahul Thakur. Tell me here. Is this points clear? Yes? Okay. So Rahul Thakur, is it clear? Alok Kumar is saying clear. Okay, right. Rahul Thakur, is it clear? If you are having any doubts, you can ask me here. Okay, clear. Right. Very good. See, after finishing the lecture, after going home, okay, so just revise all these things, just try to analyze on your own here, okay. So without seeing the lecture, so just try to analyze each and everything, whatever we have studied, just try to analyze each and everything on your own, okay. If you are getting any doubts, you can ask me immediately in the next class itself, right? Okay, okay, yeah. So this is the application here. This is the application of this Lorentz force equation. Okay. So which is Hall effect, right? Okay. Next here. Next. See here. Now here I am giving a B field. Let us assume B field is pointing into the board. Okay, so let us say this is B field. So let us consider the coordinate axis in the same manner here, x, y and z, right? Okay, okay, yeah. Okay, so here let us consider this is what? This is a conducting bar. Let us consider this is what? This is a conducting bar. Okay, so its length here, the length of this conducting bar, let us consider the length is L. The length is L. Okay, Okay, yeah. So let us say this conducting bar is moving with velocity, v. This conducting bar is moving with velocity v in this direction. Okay, so I have taken a conducting bar of length L. Now this conducting bar is moving with velocity v in x direction, So can you guess what will happen here? What will happen? Can you guess? Whenever a conducting bar, here the magnetic field lines are pointing into the board, right? Okay, now here the conducting bar is moving in this magnetic field with velocity v in this direction. So whenever a conducting bar is moving in magnetic field with velocity v, then what will happen? Can you guess here? What will happen? Can you guess? Can you guess what will happen? What is the main property of a conducting material? The main property of a conducting material is what? The free charge carriers, free charge carriers are available within the conducting material, and the charge carriers are free to move within the conducting material. So that is the main property of a conducting material. What is the main property of a conducting material here? There are free charge carriers will be available, and those charge carriers are free to move within the conducting material. Yes or no? Okay, so charge carriers are free to move, within the conducting material, Just analyze yourself here. What will happen? Just tell me. Charge carriers are free to move within the conducting material. We know this, right? Okay, so within the conducting material, free charge carriers are available, and those charge carriers are free to move within the conducting material. That is the main basic property of a conducting material. Yes or no? Whereas if you consider an insulating material, inside the insulating material there are no free charge carriers are available, and the charge carriers are not free to move within the insulating material. That is the difference between what? That is the difference between insulating material and conducting material. Understood? Okay, so inside the conducting material you are having free charge carriers, right? Okay, and they are free to move within the conducting material. So what will happen in this case? So current flow okay, can you say that specifically here? Can you say that specifically? What do you mean by current flow? Okay, first of all, why the current flows here? Rahul Thakur, why the current flows? Alok Kumar saying EMF will be induced across the conductor. EMF will be induced across the conductor. Okay. So why EMF will be induced? Why EMF will be induced? See what will happen here, already we have studied now. We are studying about Lorentz force equation, yes or no? So what will happen? What Lorentz force equation will tell? So whenever you are having magnetic field, and if the charge carriers moves in that magnetic field, then they are going to experience a force. Yes or no? So now here inside the conducting material, what are the charge carriers that are present? The charge carriers that are present is nothing but what? Free charge carriers are nothing but what? Are nothing but electrons. Yes or no? Okay, so whenever this conducting bar is moving in this direction here, whenever the conducting bar is moving in this direction, we can consider as all the electrons or all the negative charge carriers within the conducting material will also move along with the conductor or not? Yes or no? Yeah? Yes or no? So in this conducting material you are having negative charge carriers. So whenever the conducting bar is moving like this, okay, what will happen? All the negative charge carriers will also move with the conductor. Yes or no? So that means I can treat it as what? I can treat it as the charge is moving. The charge is moving within the conducting. The charge is moving within the B field. Within the B field. So whenever the charge is moving within the B field, what will happen? It is going to experience what? It is going to experience a magnetic force. It is going to experience a magnetic magnetic force. Yes or no? Now tell me in which direction these negative charge carriers are going to experience a magnetic force. Tell me in which direction they are going to experience a magnetic force. Tell me here. In which direction those negative charge carriers are going to experience a force? Here no concept of hole, Alok Kumar. Here I am calling it as conducting material. Only in semiconductors you are having the concept of hole and right? Whereas in case of conductors there is no concept of hole, right? Come out of that semiconducting material. Here I am dealing with conducting material, right? So whenever the conducting bar is moving with velocity v in this direction, then what will happen? So inside this conducting material you are having what? You are having free charge carriers. So those free charge carriers are nothing but negative charge carriers. So what will happen? All the negative charge carriers are moving like this along with the conductor. So what will happen? So whenever the charge carriers are moving in the magnetic field, they are going to experience what? They are going to experience a magnetic force. So now here the electrons are going to experience a magnetic force. In which direction? So Rahul Thakur is saying negative y direction. The same principle here, whatever we have studied, the same principle. Yes or no? We are seeing the applications of this Lorentz force equation, right? Okay. See here. So now let us consider here. Let us consider a small differential length here. Let us consider a small differential length dl, right? Let us consider a small differential length dl. So the small within this small differential length dl, the charge that is present, I can write it as what? Rho L into dl. So this is the charge I am considering over this small differential length dl. So rho L into dl, I am representing this rho L into dl, I am representing with what here? With dq. So I am considering only a small differential charge that is present over this length. Okay, so now here this dq is nothing but what? It is a negative charge. Yes or no? So I am considering it as what? Minus dq, right? Okay. So I am considering only this dq amount of charge. So I will try to determine in which direction this minus dq amount of charge is going to experience the force. Yes or no? Okay. So what I am doing here is I am trying to determine the small differential force experienced by this small differential charge. Understood? So that's why I am representing with DFB, a small differential magnetic force experienced by a small differential charge. Understood? That small differential charge is nothing but what? Minus dq, right? Okay. Okay, so this is equal to what? This is equal to so minus dq into what? Minus dq into v bar. V is pointing in which direction? X direction. So v is in x direction cross b bar. So b is pointing in which direction? Into the board. So negative z direction. Understood? Okay. So therefore DFB, a small differential magnetic force, is equal to what? Is equal to minus dq into what? Into v into b. So x cross z here. X cross z will be minus y. Minus of minus will become plus. So here you are going to get ay cap. Okay, so minus ay cap here, that means the negative charge carriers, the small differential negative charge carrier is going to experience a force, in which direction? In negative y direction. See, the resultant force will be in which direction? Minus ay cap, that means in negative y direction. So that means okay. So now I will try to determine the total force here, the total force. So how I can determine the total force here? So if I want to determine the total force, what I have to do here? I have to integrate throughout this what? Throughout this length. Yes or no? So here I am determining the small differential force that is experienced by a small differential charge. Now I want to determine the force experienced by the total charge that is present within the conducting material. Yes or no? So then what I have to do here? I have to integrate. Understood? Here charge means I am considering only negative charge carriers. Yes or no? Okay. So FB is equal to what? FB is equal to integral minus dq VB ay cap, yes or no? Okay. So here from where to where here? Let us assume here this is, let us say here y is equal to 0 and here this is y is equal to L. So the distance from here to here is nothing but L, right? Okay. So here what I am doing here is, so I am integrating from 0 to what? From 0 to L throughout the length, right? Okay. So just I am following the procedure here, you have to get habituated with this procedure, right? Okay. So here integral 0 to L, see here it is showing some error here. Are you able to, is audio and video everything clear here? Here on desktop it is showing some error. Is audio and video everything clear? Tell me. Tell me here. Rahul Thakur, Alok Kumar, is audio and video everything clear? Because on desktop suddenly it is showing some error, so that's why I am asking. Clear? Okay then. So integral 0 to L here. So this dq is nothing but what? Is nothing but rho L into dl, so V into B. So this is equal to what? This is equal to, so rho L is constant, V is constant, B is constant. So take all of them outside the integration. So you will get rho L into V into B. Integral dl is nothing but L and its range is from 0 to L. So you are going to get finally L here. Okay. So minus rho V L minus rho L V into what? B into L, right? Okay. So this V is nothing but velocity here. This V is nothing but velocity. Okay. So this V is nothing but velocity. So velocity I am representing like this. Okay. 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 So it is in which direction? Here ay cap. Okay. So this is equal to what? This is equal to minus rho L into L into what? Into V B ay cap. So this is nothing but what? Magnetic force. See, we can do this directly here, okay, but you have to get habituated with this procedure. So that's why I am doing all these things, right? Okay. You have to understand how you are doing. So FB is equal to what? Minus rho L into V into B. So rho L is the charge distributed per unit length multiplied by total length is nothing but what? Is nothing but total charge. So that means here I can replace rho L into L with what? With Q. So therefore FB is equal to what? Minus Q into what? Minus Q into V into B A Y cap. So that means the resultant magnetic force is in negative y direction. So negative y direction here. So whenever this conducting bar is moving along x direction, the negative charge carriers that are present, within the conducting material are going to experience the force in downward direction, that is in negative y direction. So what will happen? All the negative charge carriers will get accumulated at the bottom of what? At the bottom of conducting material. Why here? Because all the charge carriers are experiencing the magnetic force in downward direction. All the negative charge carriers are experiencing the force in negative y direction. Understood? Now at the other end of the conducting material, there is a deficit of what? There is a deficit of negative charge. So that you can accommodate as what here? That you can consider it as what? That you can consider it as positive charge. Understood? Okay. So because of this magnetic force, all the negative charge carriers are experiencing the force in downward direction. Right. So because of this, what will happen here? There will be a deficit of negative charge carriers at the top of the conducting material. So there here the deficit of negative charge carriers you can accommodate with what? You can accommodate with positive charge. So what will happen? Here positive charge will get developed and here negative charge will get developed. Because of this, what will happen? The electric field will get developed. Yes or no? So the same thing here, whatever we have learned, the same thing. So here the electric field is going to point in which direction? The electric field is going to point in downward direction. Now in which direction the negative charge carriers are going to experience the force? Due to magnetic field, they are experiencing the magnetic force in downward direction, negative charge carriers. Yes or no? Now these negative charge carriers are going to experience electrical force in which direction? See, the electric field is pointing in downward direction, means the negative charge carriers are going to experience the electrical force in upward direction. Just now we have seen here, right? Okay. So in upward direction there will be what? There will be an electrical force. Understood? So then what will happen here? At one stage this electrical force will become equal to what? Will become equal to this magnetic force. So initially magnetic force is present. Because of this charge separation will takes place. So because of this charge separation, there develops or there induces an electric field in downward direction. So if the electric field is in downward direction, means the negative charge carriers are going to experience the electrical force in upward direction. Understood? So as this charge separation goes on increases, then this electrical force will also goes on increases. At one stage what will happen? This electrical force will become equal to what? Will become equal to magnetic force. Understood? Okay. Yeah. So now under equilibrium condition, you can equate these two and you can get the expression for the induced voltage. Yes or no? Here the top is positive and bottom is negative. So that means there develops an induced voltage between top and bottom. Okay. Now here let us consider this end as A. Okay, and this end as what? This end as B. So you have to try to determine VAB. So follow the same procedure here. And try to determine VAB. Do it here. So here we got what? FB is equal to what? FB is equal to minus Q into what? V into B, and FE is equal to what? FE, electrical force, is equal to what? Is equal to, you are going to get minus Q into what? Minus Q into E bar, and E bar is going to point in which direction? E bar is pointing in negative y direction. So what you are going to get? Q into E into AY cap. So this is the electrical force. Understood? See, electrical force is pointing in positive y direction, whereas magnetic force is pointing in negative y direction. So both will get balanced at one stage. So that condition we call it as what? Equilibrium condition, right? Okay. So now here I'll try to get the expression of electric field in terms of what? In terms of potential. So what I will do here is E is equal to what? Sorry. So VAB here, I want VAB. So VAB is equal to integral A to B, right? Okay, VAB is equal to integral A to B E bar dot what? E bar dot DL bar. So that is equal to integral A to B. So E is pointing in which direction? E is pointing in negative y direction, and DL bar. So this is along which direction here? DL bar means which direction? See, DL bar means along this direction. Yes or no? That is along y direction. Understood? Okay. So in place of DL, I can replace with what? I can replace with dy ay cap. Okay. So dot dy ay cap. Okay. So what I am going to get here? So integral A to B E into what? E into dy. So this is equal to what? This is equal to E into integral dy, that is y, its range is from A to B. So you are going to get what? E into what? E into B minus A. E into B minus A. So this is nothing but VAB. So what is B minus A here? What is B minus A? What is B minus A? Tell me. What is B minus A? What you are going to get? You are going to get plus L or minus L. Tell me. What you are going to get here? Tell me. B minus A. So what you are going to get? Plus L or minus L? So B is at 0, yes or no? Okay, A is at L. Understood? So B minus A means 0 minus L. So that means you are going to get minus L, right? Okay. So I hope you are following here, right? Okay. So therefore VAB is equal to what? Is equal to E into minus L. You are going to get E into minus L. So here in place of A, put L. In place of B, it will be 0. Understood? Okay. So therefore E is equal to what? E is equal to minus VAB by L. Minus VAB by L. Understood? Yes or no here? Okay. Okay here. So now what will happen here? Under equilibrium. So under equilibrium condition, under equilibrium, what will happen? Tell me. So FE or FB is equal to what? Magnitude of FB will be equal to what? Magnitude of FE. We know that both are exactly opposite to one another, and their magnitudes must be what? Their magnitudes will become equal under equilibrium condition. So FB is equal to what we got here? FB is equal to okay. So consider FB magnitude here. Consider only magnitude, that is QVB. So that is equal to what? That is equal to electrical force. Magnitude of electrical force is nothing but what? E into Q. E into Q. E into Q. Right? Okay. So now here QVB is equal to what? Is equal to, so electric field E, I can write it as what? I can write it as minus VAB by what? Minus VAB by L into Q. So here Q will get cancelled. Therefore VAB is equal to what? Is equal to minus B into L, or I can say therefore VAB is equal to what? Minus BLV. We have done something. You have to get VAB positive here, right? Yes, VAB must be positive. So where we have done something wrong here? Okay. Here you are having E minus AY cap dot dy AY cap. So here you are going to get what? Minus. Yes or no? So I forgot this minus here, right? Okay. So here you will get minus E, right? Okay. So here you will get minus E. So minus E into minus L, you will get what? You will get plus VAB by L, right? Okay. Now here replace here E with what? Replace here E with VAB by L, right? Okay. So you will get positive here. You have to get positive, right? So VAB is equal to what? VAB is equal to BLV volts. This is the expression we got. So that means whenever Rahul Thakur, sir, please explain direction of electric field again. Prasad, sir, please repeat. Okay. See here. See, the magnetic force is acting in downward direction, yes or no? Okay, so all the negative charge carriers are going to accumulate in the bottom. So there is a deficit of negative charge, so that will accumulate, that can be accommodated as what? Positive charge. So here there develops a positive charge at the top, and at the bottom there develops a negative charge. So because of this charge separation, what will happen? There induces an electric field that is going to point from where to where? Plus to minus. So that means the electric field is pointing in downward direction. Right? Yes or no here? Have you understood the electric field direction? Rahul Thakur, have you understood electric field direction? The electric field is pointing in which direction? Downward direction. Yes or no? Here we are talking about what? Negative charge carriers here, negative charge carriers. So negative charge carriers are going to experience the magnetic force in downward direction, and hence all the negative charge carriers will get accumulate here, and hence there develops a positive charge here, and hence the electric field will point from plus to minus, that is in downward direction, that is in downward direction. That means it is pointing in negative y direction here. Right? Okay. So whenever electric field is pointing in negative y direction, the negative charge carriers are going to experience the force in which direction? The negative charge carriers will always experience the force in a direction opposite to electric field or not? Yes or no? So that means electric field force is going to will be in which direction? Electric field force is going to be in, the electrical force is going to be in upward direction. Yes or no? Electric field is in downward direction and electrical force will be in upward direction. Yes or no? Okay. So now what will happen? This magnetic force and this electrical force at one stage will become what? Will become equal. Will become equal. That condition we call it as what? Equilibrium condition. So here what I have done here is, so first I have taken a small differential charge here. A small differential charge I am considering minus dq. A small differential negative charge. Okay, and I am trying to determine the small differential magnetic force experienced by that small differential negative charge. So that is given by this expression, that is given by this Lorentz force equation. So dFB is equal to what? Minus dq into V bar cross B bar. Understood? Why I am representing dFB? This is the small differential magnetic force that is experienced by a small differential negative charge. Understood? Okay. So just I have solved this one here. So I have written minus dq here VB. Okay. So x cross minus z. X cross z will be minus y direction. Minus of minus will become plus. So here I am writing Ay cap. Here minus I am writing as it is. So the resultant force will be, the resultant magnetic force is in which direction? Here minus, here you are having Ay cap. That means the resultant force direction is in negative y direction. Understood? So this is in negative y direction. FB is in negative y direction. Now next, what we have done here? So if you want to determine, the total force acting on the total negative charge that is present within the conducting material, we have considered the force acting on the small differential charge. Now we are trying to determine the force acting on the total charge within the conducting material. Understood? Okay. So what I have to do here, if you want to determine the force on the negative charge carriers within the conducting material, then what you have to do? You have to integrate. You have to integrate along the length. Yes or no? So if you integrate along the length, then you are going to get what? You are going to get the total magnetic force. So that is equal to integral 0 to L minus dq VB Ay cap. So where this dq is nothing but what? Small differential charge, which we can represent as rho L into what? Rho L into dl. So I have replaced this dq with rho L into dl. Understood? Okay. So V into B into Ay cap. So if you integrate this one, what you are going to get? Here rho L is constant, velocity is constant, B field is also constant. Okay. Our conducting bar is moving with some constant velocity. Understood? B field is also constant, and rho L is also constant. So what will happen here? You can take all these constants outside. So you are going to get minus rho L into VB. So integral integral dl is nothing but L. If you substitute the range, what you are going to get finally you are going to get L. So FB is equal to what? Minus rho L into L into VB into AY cap. So rho L is nothing but the charge that is the charge that is present per unit length multiplied by the total length will give you what? Will give you the total charge. So rho L into L I am replacing with Q. So then it will become what? It will become minus Q into V into B. So the resultant magnetic force that is acting on the total negative charge that is present within the conducting material is in which direction? Is in negative Y direction. Is in negative Y direction. Understood? Okay, so because of this, what will happen? The charge separation takes place. On the bottom there is a negative charge, on the top there will be a positive charge. So because of this charge separation, there induces an electric field from plus to minus. So whenever there induces an electric field from plus to minus, yes or no? Okay, in which direction these negative charge carriers are going to experience the force here? In which direction the negative charge carriers are going to experience the force? So they are going to experience the force in a direction opposite to what? Opposite to electric field. Sorry, opposite to electric field. So that means electrical force will be in which direction? Will be in upward direction. So electrical force on the negative charge carriers is acting in upward direction, and the magnetic force on the negative charge carriers is acting in downward direction. So at one stage what will happen here? These two forces will get what? Will become equal. So at that stage the net force on the charge carriers will become 0. Understood? And the charge separation will stop. Right. So this condition we call it as what here? We call it as equilibrium condition. Okay. So under this equilibrium condition, the magnetic force must be, the magnitude of magnetic force must be equal to what? Magnitude of electrical force. Yes or no? Okay. So we try to determine the electrical force that is acting on the negative charge minus Q. So this is minus Q. The force acting is minus Q into E bar, and minus Q into electric field E bar is acting in which direction? Downward direction. So E into minus AY cap. So I can write FE is equal to Q into AY cap, QE into AY cap. So this is the resultant force direction. The resultant force direction is in which direction? Is in AY cap direction. Electrical force is in upward direction, magnetic force is in downward direction. Understood? Okay. Okay, yeah. So now under equilibrium condition, magnitude of FB must be equal to what? Must be equal to magnitude of FV. So magnitude of FB is nothing but QV into VB, and magnitude of electrical force is nothing but EQ. So here I want to represent this electric field. In terms of what? In terms of potential. Understood? So for that, what I have done here? So I have tried to determine VAB here. So VAB is equal to, we know that integral A to B E bar dot DL bar. Okay. So here electric field is pointing in negative Y direction. So E into minus AY cap dot DL bar is nothing but DY AY cap, because this small differential length is along what? Is along Y. Okay, so I am considering this as what? Dy Ay cap. So that is equal to what? Minus integral A to B E into dy. So if I take E out of the integration, then I am going to get minus E into integral dy is y. So if you substitute the range, you are going to get E into B minus A. So B is at the bottom, A is at the top. Understood? So you are measuring the length from bottom to what? From bottom to top. So at the bottom B is 0, at the top A is at the top, and the length is nothing but what? L. Yes or no? Okay. So that's what I have told here or not? See, at this location, at B, Y value is what? 0. At A, Y value is what? L. Understood? Okay. Okay. So if you substitute the range, that is B minus A will give you what? B minus A is nothing but 0 minus L, that is minus L. You are going to get minus L. So minus L multiplied by minus E is going to give you what? VA is going to give you E into L. So from here E is equal to VAB by L. VAB by L. Understood? So here I have substituted, in place of E I have substituted VAB by L. So from here I have determined VAB is equal to what here? VAB is equal to BVL, or I can write this as VAB is equal to BLV. Understood? So VAB, that means the potential difference between A and B, we got it as what? We got it as positive. Yes or no? So if you observe here, the same thing we got here or not? Yes or no? At the top we are having positive charge and at the bottom you are having negative charge. So VAB is positive. Understood? It is at higher potential and it is at lower potential. So VAB must be positive. So that's what we got here. VAB, we got it as some positive value. Yes or no? VAB, right? So for the same thing here, if you want to practice, if you want to have a practice, what you will do here is just take the B field, right? Okay, so just do it as homework here, right? So just take the B field like this. Now what you will do here is, so take the conducting bar, right? Okay, now move this conducting bar in this direction. And try to get the expression for VAB. Right. Next, what you will do here is, let us consider the magnetic field, the B field. You can take out of the page here. You can take B field out of the page. See, if you practice all these things, you will get very much familiar here, very much familiar with all these things. Okay, so this is not going to be helpful only in this subject. Okay, so it will be helpful whenever you are studying EDC or some other subjects also, right? Okay, I think for electrical students also, while they are studying machines or something, okay, there also it is these concepts are going to be very much helpful. Okay. So next take, you have to practice like this here, then you will get clarity, right? So here you take a conducting bar, and move it in this direction with velocity V. Next change the direction of B field and change the direction of velocity. So then try to determine the potential difference between A and B. So in this case also try to determine VAB. Understood? Okay. Can you do this one here just as a practice? So just do this one here, just do this as practice here. See, if you do whatever the homework problems that I am giving, so if you do that, then you are going to get some crystal clarity on the topics here, right? So if you practice this one, similarly whatever I have followed the procedure, so follow the same procedure and try to get the expressions for VAB. Understood? Okay. So it's just like it will be a practice here. It will be a practice for you, right? If you do this on your own, then you will get crystal clarity, okay, on this procedure, whatever we have done, right? Okay. So can you do this one here? Tell me. Can you do this too? Tell me here. Prasad, is it clear here? Tell me, Prasad. You have asked me to repeat, so I have repeated everything. So please let me know, have you understood clearly? Tell me, Prasad. Prasad, is it clear? Rahul Thakur, Alok Kumar, tell me here, is it clear? Whatever we have studied up till now, is each and everything crystal clear? Tell me. Prasad, yes sir. Okay. Rahul Thakur, Alok Kumar, tell me here, is it clear? Okay, Prasad, very good. Okay. Tell me, Alok Kumar, Rahul Thakur, is it clear? Yes. Okay. Will you try these examples here? Will you try this one? You can take here, you can take randomly, you can take a B field out of the board or into the board, right? Okay. And try to move the conductor in that field and try to determine VAB, the potential difference between top and bottom. Okay. So these things, please try this at home here, right? Okay. So let me know the answers tomorrow. So do this one and this one as homework, okay? Or if you want, you can take another also. You can change the direction of B field and you can change the direction of velocity. So you can what I am saying is you can create one more problem, right? So for that also you can practice, right? So if you practice all these things here, if you practice all these things, this would be very much helpful, not only in EMT but also while dealing with machines or something, okay? In those subjects also it is going to be very much helpful. And for electronic students, if you understand these things, then you can it will be helpful while dealing with what? While dealing with EDC, right? Okay, okay, yeah. Okay, yeah. So everybody, okay, yeah. So with this I am winding up the session for today, okay? So practice these things here. So with this I am winding up the session for today. So tomorrow, yeah, tomorrow exactly at 4 p.m. Tomorrow also the session will be exactly at 4 p.m. right? Okay, okay, yeah. So I hope each and everything is crystal clear. So with this I am winding up the session for today. So tomorrow also at the same time, 4 p.m. we are going to meet here. So one more thing I want to tell is to the students, please be safe here, because now the situation is going worst, okay? So please be safe and take care and keep learning, right? Okay, so we will meet tomorrow exactly at 4 p.m. So until then, take care, bye bye, right?